All right, today I want to talk about the command line's role in interacting with computers, as well as addressing complexity reduction. To start with, I have to talk about what a graphical user interface is. Overall, there are many tasks to be done with a computer. The main medium with which most people go about accomplishing these tasks is through a graphical user interface. It's primarily navigated using a mouse as well as a keyboard. GUI design primarily uses stuff like windows, icons, menus, and pointers to provide organized structure for user interaction. Uh, Common elements used to achieve this are buttons, text fields, checkboxes, and sliders, stuff that we all use every day. For most users, this is the only way they've ever really interacted with their computer. Here's the Steam storefront page. This has everything a GUI is described to have. You have the drop-down menus, the text boxes, an organized structure, and we have the shell, which is also called command line interface. This is actually the original way that people used to interact with their computers before GUIs were even a thing. Once you start needing to do things like develop software, act as a system administrator, work with large data sets, or many other tasks, a GUI either becomes inefficient or even ineffective completely, depending on the task. It's mainly a textual interface that allows users to interact with the underlying operating system by issuing commands. The most common way of using a CLI on a modern computer is through the use of software known as a terminal emulator. You might know Command Prompt or PowerShell for Windows, and Bash is on both Linux and macOS. Here's an example of the CLI. I first have this picture here of just a blank prompt. You have the user, the name of your machine, and you have a cursor, which you then type in commands. Then over here, I've done two different commands to kind of show you generally how this works. Why use the shell? The shell can perform a variety of tasks, including file system navigation and interaction, the use of version control systems like Git, installing packages using a package manager like apt. The shell also bridges the user and operating system kernel, allowing for direct interaction with system resources. When used well, many common tasks can be automated in a way that requires very little effort on the side of the user. And overall, the shell boasts superior efficiency, speed, control, precision, and lower resource consumption to accomplish tasks. Why do more people not use the shell? Common issue people new to CLIs face is having to memorize complex commands and syntax without visual cues to navigate the interface. Due to there being so many different commands, it can be overwhelming to even begin to approach learning for some people, as well as fear of error can also be a roadblock people struggle with. Since there's no visual component, it can also run counter to how people are used to interacting with the computer. The paper I chose in relation to this topic I've discussed so far is called An Empirical Investigation of Command Line Customization. The paper analyzes more than 2.2 million shell alias definitions on GitHub. An alias is a name you can assign a string value that defines a command or chain of commands. The paper aims to not only record the most common aliases defined, but to also figure out the implications this data can have on improving the command line experience. The way that this paper organizes and shows you this information is through these following types. It provides three main types of aliases that people use: shortcuts, modifications, and scripts. Shortcuts include nicknaming commands, abbreviating subcommands, and bookmarking locations. For modifications, there's substituting commands, overriding defaults, colorizing output, and elevating privilege. And finally, scripts have transforming data and chaining subcommands. And honestly, even without going in further depth, the way that it's phrased, at least for me, it's very self-evident about what these things are trying to achieve. Then we have shortcuts, nicknaming commands. It's a very commonly used type of shortcut when creating these aliases. It just gives a new name to a command without adding any arguments and without it being a command that's already existing. The nicknames that are used most often include G to invoke the git command, C for the clear command, H for the history command, and V for the vim command. Having C for clear, especially in my eyes, is really nice because the clear command is how you flush all the output that's currently on your screen and bring you back to this screen. So if I were to type clear here, this would all go away and go back to here. So that's nice. You can even do this to act as a sort of makeshift autocorrect mechanism. And so, these kinds of mistakes happen all the time, and you can just set up your system in a way to where it catches you and you don't get taken away from your work just by making a simple mistype. The second part of shortcuts now, in order to understand abbreviating subcommands, you first have to understand what a subcommand is. A good way of visualizing this would be the main command would be an application you're using, whereas the subcommand would be an action that you want it to do. And to illustrate this, get's very commonly used with quite a lot of subcommands. Get status is something that you'll use all the time. Get here would be the main command, and status would be the subcommand. You can make GS a substitute for get status, just as opposed to typing out two separate words, you can just make it two letters. When using the shell, you'll want to access directories or domains. Bookmarking locations allows you to make aliases to quickly access the locations you want to utilize frequently. Good example of this is if you want to access your downloads folder to make use of the files you have stored there. You can make DL the alias for typing in cd home directory slash downloads. There are commands that do some things better than something another command already does. Substituting commands is a type of alias that allows you to create a name identical to the name of an already defined command. A common example for this is more being used as an alias for less, replacing standard Unix utility with a more capable or similar command. Another use case common with this is subterfuge, as in the case with Emacs being used as an alias for Vim and vice versa, which is funny because there's always been a back and forth between which program is better. Overriding defaults is used primarily with the command's arguments. This type of alias has the actual command name itself remain the same. It just redefines the default settings of the command affected. Perfect example of this is if I want to see the contents of my current working directory, I can use the ls command to see it. This command has many potential arguments that change how the information is output to the screen. This type of alias allows you to make it to when you type ls, it acts as if you typed ls-l. Colorizing output is a significant action aliases are used to enable by default. You can do this in many ways. You can add arguments to commands, so like less-r will colorize the output. Setting an environment variable, which is system-wide configuration information that acts like global settings for your applications to run in your current session. Run a command through a tool that colorizes its output, as well as replacing a command entirely, so using diff as an alias for color diff. Many commands do things that need to interface with or modify critical parts of the system. To use these commands, you need to give them super user privileges. As an example, normally to update a Linux system, you would need to type sudo apt update so that the apt command has proper permissions to access the resources necessary to execute the update subcommand. An example of using the elevating privileges type of alias would be to make the alias name update execute sudo apt update. To understand the transforming data type of alias, understanding the pipe operator is important. It allows you to create a pipeline of multiple commands that executes from left to right, passing its output to the next command. As an example of this, you would type du-s pipe sort-n-r pipe more. You can alias that entire pipeline as just disk space. Chaining subcommands is a pattern in alias scripts which are chains of subcommand executions. An example of this would be brew update double ampersand brew upgrade. And it's a chain of subcommands that you can then assign to an alias name like brewup. So the main takeaways from this is that learning command line can be challenging. It's a lot to learn. Despite this, the more you learn about the topic, the more ways there are to make utilizing it faster and easier. The way that I look at it anyway is that you can understand a lot more about the commands you're using by working through ways to alias the common commands that you use every day. I believe the paper does a good job of being able to categorize these aliases, showing people proven directions for reducing complexity. And I believe being able to use a powerful tool like this and personalize it to make it work the way you want shows how impactful it is and how we interact with computers.